angle of the blades, and that was very successful. And we have here a quick video that the Mastcam Z took of the helicopter spinning in the distance. So from there, the rover was about 40 meters away. And so we're able to look at the telemetry in very good detail and verify that the blades moved and the blades spun as expected, and it looks very good. So what's it going to be when we fly? So the flight, as Mimi mentioned, will happen at 12:30 in the afternoon on Mars time, which will be about 8 p.m. on Earth time on Sunday. And then later on in the evening, the data will be relayed back to Earth by the Perseverance rover through an orbiter, and then we will be waiting here in the control centers at NASA for that data to come in. We're expecting that data around 12 midnight, early Monday morning. And so what's the first flight going to be? It's going to be a very careful flight just to do the very first checkout, because it'll be our first flight. And we're going to lift off. We're going to go up to about 3 meters. We're going to rotate in the direction of the rover, and we're going to take a picture, and then we're going to settle back down. The whole flight, from the moment the blades spin up until we land again, will be about 40 seconds worth of time. That's the time we felt safe doing it on our first flight, given the energy levels that we're seeing, and we want to make the very first flight a safe one. As you can see in the accompanying animation, that's what the flight will look like. So one of the nice things about the helicopter is that it has cameras on board, and we have a downward pointing black and white camera that we use to do our navigation. It's fused with other sensors like an inertial guidance sensor and an altimeter. And as we're flying, we're taking pictures 30 times a second of the surface, and the software is detecting features. And then as the helicopter moves, those features move with it, and the helicopter can do an estimate of what the rate and direction of the helicopter motion is. So that black and white camera is our primary camera that we use for navigation. Here is a picture that we took downward facing on the day that we dropped. And you can see it's slightly overexposed, but we've been tuning it over the last few sols to get better pictures. But that's really the view, what the helicopter is going to see while it's flying, and it'll pick out those features on the ground, the rocks. That was one of the reasons we selected this terrain, is because the features are very nice for that feature tracking. So as those features drift, the software can detect that drift. Secondly, we have a 13 megapixel color camera that's pointing towards the horizon. And that picture, will take a few of those pictures during each flight so that we'll get a live picture as we're aloft. And here's a picture underneath the rover on the day that we dropped. Now, there was a picture that went out that was a low resolution version of this picture, but in the meantime, we've been able to retrieve the high full glory 13 megapixel picture, and that will be out on the NASA website soon. So this is kind of an idea of what kind of resolution that we'll get from those pictures as we take them. So what will we be doing the night of the flight when the data comes in? We have our downlink team that will be watching carefully as that relay happens from the rover through the MRO orbiter back to Earth. We'll see the data show up in the data center, and then our downlink engineers will start to decode all that data. And the first thing we want to do is to verify that we got the data correctly. And at that point, once we confirm that the data has arrived, we will turn it over to Hovard Grip, who is our chief pilot, and he will look for very specific events in that data that indicate that the helicopter took off, did the hover, did the rotation, and then came back down and landed successfully. So that's the first thing we'll look at. And then what we'll do is we'll jump to our altimeter data. We have a laser altimeter, and we'll do a plot of that altimeter data to see that we rose, hovered, and then came back down. And at that point, we'll be able to confirm, yes, we did really take off. And we'll be able to then look at images, that black and white navigation camera that I mentioned. It will be taking these downward pictures, and we'll be taking some images as we come down that help us check for sure where we landed. And so we'll be able to see that on the day of the flight. The color camera pictures that I mentioned, we will be downlinking them the day after the flight. So we'll be very excited to see what kind of picture was taken during that flight time. Once we've seen the altimeter, and the helicopter team is super excited because we've confirmed that we did that first flight, then we should be able to see some imagery from the rover itself. The rover is going to use that magnificent Z-Cam instrument to attempt to take video during the flight. We've been practicing that over the last few sols with the blade release and the 50 RPM spin to try to synchronize our timing. And so far, it's gone really, really well. So we thank the Mastcam Z team for that. And so on the day of the flight, when we're downlinking that data, once we confirm that we flew via that altimeter data, then we can turn it over to the rover team and see what kind of imagery they got for the actual flight from the rover itself. So we're really excited. It could be an amazing day. We're all nervous, but we have confidence that we've put in the work and the time, and we have the right people to do the job.